Welcome to my roller coaster video. So, um, before we actually show you my roller coaster, I want to go over the requirements. So the roller coaster needs to have 5 hills, 2 loops, a straight path, and use at least 7 different functions. And we have to state obviously all the domains and ranges, and it has to be safe and look relatively fun. So let's start off here. So firstly, I think that my roller coaster should go, and I've designed it so that 0 is where it starts, and it will end all the way down somewhere around 53. So that's my plan. And so I start with a exponential function here. So you start your roller coaster, you're going, going, you're going. And I've used an exponential function here to describe this. And these ranges that are stated here, so like that y has to be greater than 4 point or less than 4.371 and x has to be greater than 0. These are determined and played around with based on me actually designing the roller coaster, so we'll see how it develops. So the next stage after this, I wanted a quadratic, so a flipped quadratic to be coming like that and going down. So then I added this. So we can see here the quadratic here, and we stopped the quadratic based on, we defined it based on domain here so that it will stop here and then we'll continue. So at this point over here, I wanted there to be a loop. Okay, so I want this thing to enter right into a loop. So we created this oval equation, and so this thing will enter into a loop, so it'll go up and down, but then after it, I want it to exit the loop, and I want it to exit on a straight path. Okay, so we've already had one loop and one hill um, for our roller coaster. So we're going to go right into a straight loop. So we can see here that it exits at 1 when y is 1. So we add here y equals 1. So this is our straight path here now. And within the straight path, I actually wanted to add in another loop. So we added another loop, a little bit of a smaller loop. Obviously, physically speaking here, we don't want this second loop to be like higher than the first one because of conservation of energy. So obviously, you don't have to be exactly accurate here, but this sort of visually and theoretically here makes sense that you do one big loop, then a bit of a smaller loop. You want the addition of both of these loops to not be bigger than the hill that this goes. So you see how we're gaining energy here as we're going all the way up until this point. So we need that the energy gained can't be equal to can't be less than basically the energy that we're using in these loops to go up these hills, but I think we're fine over here. So after this, I added in this cubic function. Okay, so this is where you can get fancy with adding in different types of functions. I mean, this does not look like a cubic function, but I wanted a hill here, and then cubic functions have properties where they go up and down. So basically, you can truncate your own cubic function to have your own ramp. So, and you can see here that at the next stage, the ramp continues and goes down based on a sine function. So how you can see here that we use two different functions here as part of this ramp and hill. So after this, what I wanted to do was I wanted to add in a bunch of hills going up and down and up and down and up and down. So I connected for my sine function over here, I connected a cos function. Okay, so you want to make sure that when you're designing these types of things that it flows. Okay, so this took some time to actually line up properly, and it'll take you time when you do some stuff that are similar. But this kind of makes sense. Okay, so it goes down, it flows. There's no real part that it just like jumps. Okay, and then we'll go up and down. And I believe here we have 1, 2, 3, 4, 5 hills. We have 5 hills, and we have to add in one more loop. So that's what I did. I added another loop at the end here. And at this point, so this is like not as much of an oval loop, but a circular loop. And at this point now, I'm ready to sort of exit my roller coaster. And so I created a linear equation, and this was quite hard to do because, as you can see here, this linear equation in reality will go all the way down forever and all the way up forever. So I really just picked a little bit of a piece of this, so just a tiny ramp. And from this point on, I had to connect this to, so in similar fashion, at the beginning of my roller coaster, I had an exponential function as it enters the roller coaster. So as it exits the roller coaster, I also wanted to have another type of exponential function. So that's what I did. So I added in a final exponential function that connected based on the domain and range to the linear equation beforehand. So obviously this function will never touch x equals or y equals to 0, so it'll never actually touch the ground, but it's close enough, and in your own projects you can do the same thing over here. So this is my entire roller coaster. Thanks for watching.